The most important thing about adding vectors is the idea of adding them by component, meaning add like components together. So if I have a vector, some generic vector, c equals a plus b, to find out c, its full vector, both size and direction, I need to first find its components as follows. Cx would be equal to ax plus bx, and then separately cy is equal to ay plus by. Now, once I find cx and cy, I can add those vectorially, either graphically or using trigonometry, to find how big c is and in what direction. So when we're thinking about our kinematic equations for constant acceleration, if I write down a two-dimensional or multi-dimensional form, I'd say a full vector r, okay, final, equals its initial position plus v full vector delta t, this be initial, plus 1/2 a full vector delta t squared. Well, how do I add that? Let's say I have a value for the initial velocity and I have a value for the acceleration. How do I find these? Well, I either have to graphically add these tip to tail method, or I need to find their components. And so immediately I'm going to change this into, in two dimensions, two different equations. I can take off the vector signs by having clear subscripts and say this is x final equals x initial plus v initial x delta t plus 1/2 ax delta t squared. And likewise, y final equals y initial plus v initial y delta t plus 1/2 ay delta t squared. And if it was three dimensions, I'd have a similar equation for z. The importance of writing these subscripts and writing it out thoroughly is it helps me to clarify that if I have an initial velocity in the x alone and an acceleration in the y alone, I'm not going to put anything here. This will be 0, and this will be 0. So that helps me to keep things consistent. This is adding the components together separately. Once I'm done, I can find r final by saying r final as a vector is going to be equal to x final x hat plus y final y hat, and I can then find my equation, my final value that way. Likewise, I could find any one of these other unknowns as needed. The important thing is separating out their components completely so that I never add an x plus a y. So for example, I should never have x final equals x initial plus v initial y delta t. I should never have this. This is an incorrect equation.